Welcome to 15-Minute Discourse. Today we're tackling a concept that sounds like it's straight out of science fiction. Space elevators. We've got a ton of research and articles, and we're ready to explore everything from the materials we'd need to the wild engineering challenges, and of course all the potential applications.
It really captures the imagination, doesn't it? It's an idea that's been around for a while, but new developments in material science are making it feel a lot more, well, realistic.
So for anyone just joining us, let's start with the basics. What exactly are we talking about when we say space elevator?
Okay, picture this. A structure, a ribbon, stretching all the way from the Earth's surface to geosynchronous orbit.
Geosynchronous orbit being, for those who need a quick reminder, the altitude where a satellite stays above the same point on Earth.
Right, exactly. And the way this whole thing works is basically a balancing act. Gravity's pulling down on the ribbon, especially the part closer to Earth.
Okay, I'm picturing that.
And at the same time, you've got centrifugal force pulling outward at the top because of Earth's rotation. So these two forces create this incredible tension, keeping the entire structure taut, like a giant cosmic tightrope, you could say.
A tightrope that's 144,000 kilometers long? That's like going from New York to Los Angeles 30 times. I'm starting to see why this is such a challenge. And I know early proposals for space elevators always ran into the problem that, well, the materials just weren't strong enough to handle those kinds of forces, right?
Absolutely. That was a major roadblock for a long time. But then came this incredible discovery in 1991, carbon nanotubes.
Ah, yes, carbon nanotubes. I've heard about these. Microscopic structures with amazing strength.
They have a strength-to-weight ratio that's about 100 times greater than steel, which is mind-blowing.
So carbon nanotubes are the key to making this whole space elevator thing actually work.
Potentially, yes. They've become the leading candidate for building the space elevator ribbon because of their unique properties.
It all sounds very promising. But even if carbon nanotubes are as amazing as they seem, wouldn't we need a massive amount of them? And I mean massive, a ribbon that's thousands of kilometers long. Is that even possible?
That's a big one, yeah. Right now, carbon nanotubes are mostly produced in small quantities, mainly in labs. Scaling that up to the industrial level that we'd need for a space elevator, well, that's a huge hurdle that we're still working on.
So materials are a big challenge, that's clear. But I'm also thinking, how would we even power vehicles going up and down this thing? We can't exactly plug it into a giant outlet in space.
Now, that's where some really fascinating concepts come into play. One of the most promising ideas is using lasers to beam power wirelessly. You'd have climbers equipped with photovoltaic cells, kind of like how we charge our phones wirelessly, but on a much, much grander scale.
I like that idea. Very clever. But now I'm thinking about the fact that this ribbon would basically be hanging out in space. What about all the space debris out there?
You're right, space debris is definitely a major concern. Researchers are looking into a multi-layered approach to deal with that, though. That means really advanced tracking systems to try and predict and avoid collisions. And they're also working on designs for the ribbon itself to make it incredibly strong, maybe even self-repairing, so it can withstand those smaller impacts.
Wait, self-repairing? How would that even work?
Think of it like having multiple strands of the ribbon for redundancy. And you could incorporate robotic repair mechanisms that could patch up any small tears or punctures. That's definitely still in the early stages, but it's an area of active research.
It sounds like there's a lot of thought going into making this as safe as possible, which is good to hear. But I'm thinking, we're talking about a structure that's anchored to Earth and goes incredibly high. Wouldn't lightning strikes be a major problem?
That's a great question, and you're absolutely right. A structure that high would basically act like a giant lightning rod. So engineers are exploring different solutions for that, like coatings that would help dissipate electrical charges and even strategically place lightning arresters along the ribbon. The idea is to try and divert those strikes away from the main structure.
So it sounds like building a space elevator from Earth is incredibly complex, to say the least. But what if we started smaller? What if we shifted our focus to, say, the moon? Would that be more feasible?
That's an idea that's gaining a lot of traction. A lunar space elevator is definitely seen as a more manageable project, primarily because the moon's gravity is much weaker than Earth's. That means there's significantly less stress on the structure. Plus, there's no atmosphere on the moon to worry about, so no wind, no weather to contend with.
So no worries about giant moon dust storms messing things up. And you mentioned earlier that we might even be able to build a lunar space elevator with materials that we already have. What makes those materials suitable?
There's a material called Xylon, which is a high-strength composite. It's known for its incredibly high tensile strength relative to its weight. Now, it's not quite as strong as those carbon nanotubes we talked about for an Earth-based elevator,
Okay, so not quite as futuristic.
but it's something we have right now, and it could potentially handle the stresses of a lunar elevator.
That's amazing to think about. So let's say we have our Xylon and we're ready to start building. Where on the moon would we put this thing? Does it matter?
Location is absolutely crucial. The best spot for a lunar space elevator would be one of the lunar poles, and more specifically, a point called the lunar L1 point. Now, this is a point of gravitational equilibrium between the Earth and the Moon. It's where the gravitational forces of both bodies basically cancel each other out.
So it's like a cosmic balancing point. But why is that the perfect spot for our elevator?
Because it lets us extend the elevator's ribbon outward from the Moon towards the Earth, so it creates this direct link. That opens up all sorts of possibilities for transporting materials back and forth, and maybe someday even people.
It's not just an elevator on the moon. It's like a bridge between Earth and the moon. This is getting really exciting. But I have a question. What about the other end of the elevator? The part that stretches out into space? Does it just keep going forever?
Not quite. It needs to extend far enough to reach a point where the centrifugal force pulling outward is balanced by the Moon's gravity. And that's where we need our counterweight.
Right, the counterweight. We talked about that with the Earth-based space elevator, too. Can you remind us what that does again?
Think of it as an anchor at the far end of the ribbon. It keeps that whole structure taut. Without it, the whole thing would just collapse.
Okay, yeah, that makes sense. But what could possibly serve as a counterweight for something like this? What could we even use?
There are actually a few different options. One idea is to capture an asteroid from a near-Earth orbit and very carefully position it at the end of the ribbon.
Whoa, we're talking about lassoing an asteroid. That sounds pretty wild even for this conversation.
It does have a bit of a sci-fi feel to it, doesn't it? Another possibility is to actually build a large structure in space using materials that we mine from the Moon itself. So we'd essentially be constructing our own counterweight.
Okay, both of those options sound incredibly challenging,
Right.
but you're right, that's part of what makes space exploration so fascinating. Now, I'm curious about the ribbon itself. Obviously, it needs to be strong, but what other properties are we looking for? What else is critical?
Well, flexibility is really important. The ribbon has to be able to bend and flex, in response to the gravitational forces from both the Earth and the Moon.
Hmm.
It even has to be able to withstand the pressure from solar wind. Imagine a giant flexible cable, sort of like the ones you see on a suspension bridge, but, well, much bigger.
So we're not talking about some rigid pole sticking straight out from the moon. What about durability? This thing is going to be exposed to, well, space. And space is not exactly known for being a gentle environment.
That's a big one for sure. The ribbon needs to be able to handle those extreme temperatures, the radiation, those tiny micrometeoroid impacts, you name it. It's a tough job. This is where material science really comes into play. Researchers are working on things like advanced coatings and new materials that can drastically increase how long these structures can last in space.
Wow, so we need something that's strong, flexible, durable, and I'm assuming lightweight too. It's a tall order.
It's a challenge, no doubt. But the rewards could be immense. Just think about it. We could have large-scale lunar exploration, resource extraction, even the possibility of permanent human settlements on the Moon.
Now that's a future worth working toward.
Yeah.
But how do we get from, talking about it to actually making it happen? How do we actually build this lunar space elevator?
That's where things get even more interesting. The idea is to use resources that we can find right there on the Moon.
So like lunar mining operations.
Oh, exactly. The Moon is rich in resources like aluminum, titanium, and even water ice, believe it or not. We could use those resources to build the ribbon, the counterweight, even the climbers that would travel up and down the elevator. It's like creating this self-sustaining ecosystem on the Moon, using the Moon to build the infrastructure to further explore and utilize, well, the Moon.
That's really remarkable. So let's say we've built our lunar space elevator. What's next? How do we actually use it?
Well, I think the most obvious application is transportation. This would be a much more cost-effective and efficient way to move things between the lunar surface and a space station in lunar orbit, like materials and maybe eventually people.
So we could send up mining equipment, scientific instruments, even astronauts, all without those super expensive rocket launches.
Exactly. And we could bring things back down, too.
Yeah.
Lunar resources, scientific samples, maybe even lunar tours someday, all without having to rely on traditional rockets.
It's like building a cosmic highway system between the Earth and the Moon.
I like that, a cosmic highway. And it doesn't stop there. We could build large habitats on the moon, scientific outposts, even industrial facilities, all supported by a steady stream of supplies and people coming and going via the space elevator.
That's truly revolutionary. It's pretty amazing to think about a future where we could actually make lunar development and exploration much more accessible and sustainable. So we've covered a lot of ground talking about lunar space elevators, and it really seems like this could be a game changer. But I'm still kind of stuck on the how. How do we actually build something this massive?
Well, it all starts with acknowledging that we're not talking about just building a really tall tower, right? This is a system.
Hmm.
And a lot of the answers to how are actually going to be found on the moon itself.
Okay, I think I see where you're going with this. We've talked about using lunar resources, but can you break that down a bit more? What specifically are we talking about?
So the moon, lucky for us, is pretty rich in resources. We're talking aluminum, titanium, and believe it or not, even water ice.
Wait, water ice on the moon, isn't it incredibly dry?
It is on the surface, but there's evidence of water ice trapped in permanently shadowed craters at the poles. And that water ice is incredibly valuable, not just for, drinking water, but also as a potential source of hydrogen and oxygen, which we could use for rocket fuel.
Right, I remember reading about that. That's a pretty big deal if we can figure out how to extract it.
Exactly. So the idea is to set up mining operations on the moon, extract these resources, and then, here's the kicker, use those resources to manufacture the components for the space elevator itself.
Wow, so we're talking about building the elevator with materials sourced directly from the moon? That's incredible. But how would we actually go about doing that? I mean, it's not like we could just ship up a bunch of construction equipment.
This is where robotics comes in. The plan is to rely heavily on robots for pretty much every stage of the process, the mining, the transportation, the actual construction.
So basically a giant robotic construction crew on the moon. That's fascinating. But doesn't that raise a whole bunch of new challenges? I mean, we're talking about operating robots in a pretty harsh environment, millions of miles away.
True, it's not going to be easy. But think about how far robotics has come in just the past few years. We have rovers exploring Mars, robotic arms performing delicate surgeries. The technology is advancing at an incredible pace. And we can design these robots specifically for the lunar environment, make them incredibly robust and adaptable.
So if we could pull this off, we'd essentially be creating a self-sustaining system on the moon, right? Using lunar resources to build the infrastructure we need to further explore and utilize the moon.
Precisely. It's a pretty amazing vision when you think about it.
I'm sold. It's incredibly ambitious, but incredibly exciting. I'm curious, though, about the people part of all this. Where do humans actually fit into this whole lunar space elevator scenario? Are we just going to be watching from Earth as robots do all the work?
Well, initially, yeah, a lot of the heavy lifting literally will be done by robots. But that doesn't mean humans won't have a role to play.
Okay, good. I was hoping you'd say that.
We'll need skilled engineers and technicians to design the systems, oversee the construction, and troubleshoot any problems that come up, at least in the early stages.
Right. Makes sense. But I'm also thinking about the bigger picture. Once this thing is up and running, what are the possibilities for humans actually living and working on the moon?
That's when things get really interesting. Imagine having permanent research stations on the moon where scientists can study lunar geology, astronomy, even the effects of long-duration space travel on the human body.
That's a whole field of study we're just starting to scratch the surface of.
Exactly. And we could even start thinking about lunar industries, manufacturing products in the unique environment of low gravity. We could have lunar factories producing everything from electronics to pharmaceuticals, potentially even using 3D printing with lunar materials.
Wow. A whole lunar economy fueled by a space elevator. That's mind-blowing. And I know people are already dreaming about space tourism too, right?
Of course. I think a lot of people would jump at the chance to visit the moon if it were more affordable and accessible.
I know I would.
A lunar space elevator could potentially make that a reality for a lot more people, not just, billionaires. It'd be this incredible experience, seeing the Earth from the lunar surface, experiencing that low gravity. It'd be life-changing.
Okay, I'm officially adding ride a lunar space elevator to my bucket list. But let's get back to the practicalities for a moment. We've talked about the incredible potential of this technology, but we also have to address the elephant in the room, right? The cost. This is going to be a massive undertaking requiring a huge financial investment.
You're absolutely right. It's not going to be cheap. We're talking billions, maybe even tens of billions of dollars. And that's not even factoring in the ongoing maintenance costs. But I think it's important to view this as an investment in the future.
Right, not just an expense. But even if we can secure the funding, There's still going to be technical challenges, right?
Mm.
This is a complex engineering project unlike anything we've ever attempted before.
Absolutely. But if we look back at history, we see that humans have achieved some pretty incredible things when we set our minds to it.
True. The Apollo missions, the International Space Station, the Human Genome Project,
Hmm.
these were all huge, complex endeavors that required overcoming incredible challenges.
And we succeeded. So I think the key is to approach this with a sense of optimism and determination. We need to foster international collaboration, bring together the brightest minds in science and engineering, and be willing to push the boundaries of what we think is possible.
I love that. It's a challenge, but also an opportunity, a chance to really push the limits of human ingenuity. I'm curious, though, are there any specific technologies or breakthroughs that we're still waiting for to make this a reality? What are the missing pieces of the puzzle, so to speak?
Well, as we've discussed, material science is crucial. We need materials that are incredibly strong, lightweight, and durable enough to withstand the harsh conditions of space. And while we have some promising candidates, like Xylon and carbon nanotubes, there's always room for improvement. We need to keep pushing the boundaries of material science to develop even stronger, more resilient materials.
So stronger than steel, but lighter than a feather. That's quite a challenge.
It is. And then there's the whole area of robotics and automation. We need robots that can operate autonomously in the challenging lunar environment, perform complex tasks, and even repair themselves if necessary.
It's like we need a whole new generation of robots, specifically designed for space exploration and construction.
Exactly. And then, of course, there's the challenge of actually building and deploying this massive structure in space.
Yeah.
We'll need advanced propulsion systems to transport the materials and components to the moon.
And we'll need to develop techniques for assembling the structure in space, which is no small feat.
You're right. We're talking about deploying a ribbon that's hundreds of thousands of kilometers long. It's going to require incredibly precise maneuvering and a lot of ingenuity.
So it sounds like we have the vision, the potential benefits are clear, but there's still a lot of work to be done before this becomes a reality.
There is, but I'm confident that with continued research, investment, and collaboration, we can make it happen. I think the development of a lunar space elevator would be a defining moment in human history. It would symbolize our commitment to space exploration and our ability to overcome seemingly insurmountable challenges.
It would certainly be a testament to human ingenuity and determination. But beyond just the technical achievement, I think it's important to consider the broader implications, right? What would this mean for humanity as a whole?
It's pretty amazing to think about, how we could go from like sci-fi concepts to actually building something like this. It really speaks to our drive to explore and push the boundaries.
And it's not just about the cool factor. The potential benefits of a lunar space elevator are huge, right? We've talked about revolutionizing transportation, accessing resources, even opening up new frontiers for scientific research and space tourism.
It's all on the table, but, I think it's also important to be realistic about the challenges ahead. Building a lunar space elevator would be a monumental undertaking. It's going to require a major financial investment and some serious global cooperation.
We're talking billions, maybe even tens of billions of dollars, right? And then there's the whole technical side of things. Building and maintaining a structure that stretches over, what, 384,000 kilometers?
Yeah.
That's mind-boggling.
It's daunting, no doubt. But history has shown us that we can do amazing things when we set our minds to it. Look at the Apollo program. We landed humans on the moon in less than a decade.
Or the Human Genome Project. Mapping the entire human genome was once considered impossible. But we did it. These were ambitious projects that pushed the limits of science and technology. And in the end, they completely changed our understanding of ourselves and the universe.
Exactly. And a lunar space elevator could be the next great challenge, something that inspires innovation, brings countries together, and, sets the stage for a whole new era of space exploration.
Okay, so let's say, just for fun, that we do overcome these challenges. What does a future with a lunar space elevator actually look like? Paint me a picture.
Imagine a world where access to space isn't just for governments and giant corporations anymore. With a lunar space elevator, the cost of getting things to and from the moon would drop dramatically.
Smaller companies, research institutions, even individuals could get involved.
Yeah. We could see a boom in lunar mining, extracting things like helium-3, which could be used as fuel for fusion reactors. Or rare earth elements. Those are super important for all sorts of electronics and technology.
And I'm thinking about all the scientific advancements we could make. Permanent research outposts on the moon, studying lunar geology, astronomy, you name it.
Right. And then there's the human factor. We could study the long-term effects of space travel on the body, something we can't really do here on Earth. We could even see the rise of lunar industries, factories producing all sorts of things in the unique environment of low gravity, maybe even using 3D printing with those lunar
A
materials.
whole lunar economy powered by a space elevator. It's amazing to think about. And of course, we can't forget about space tourism.
Of course not. Imagine taking a trip to the moon, not just for billionaires, but for, regular people.
Sign me up.
It would be an experience like no other, seeing Earth from the lunar surface, walking in low gravity. It would change people's perspectives, inspire new generations of scientists and explorers.
It's like a pretty incredible vision. So after this deep dive into space elevators, I'm honestly more convinced than ever that this is a future worth fighting for.
It's audacious, right?
Totally. But it also feels attainable. And it's not just about the technology itself. It's about pushing the limits of what we think is possible, about becoming a truly spacefaring civilization.
Absolutely. It would be a testament to human ingenuity, our drive to explore, our ability to work together to achieve something truly remarkable.
Well said. So to wrap things up, we've explored the science, the challenges, and the incredible potential of space elevators. It's a concept that just a few decades ago seemed like pure science fiction. But now, with advancements in engineering and material science, it's starting to feel like, well, a possibility.
A real possibility.
And whether it's an Earth-based space elevator or a lunar one, the implications are massive. We're talking about transforming space exploration, opening up new frontiers, maybe even changing the course of human history.
It's definitely a future worth pondering, a future worth striving for.
What do you think? Is the space elevator a realistic goal, or is it just a fantastic dream?
We'd love to hear your thoughts. Leave us a comment and let us know what resonated with you from this deep dive.
And if you enjoyed this episode, be sure to like and subscribe to 15-Minute Discourse for more fascinating explorations into the world of science and technology.
Until next time, keep looking up.